Introduction to Trigonometry. I'm Anil Kumar, sharing with you test problems so that you can prepare for your own test. Question number 6 here is, determine the length AB and angle X. So that's the diagram given to you. This is the angle X which you need to find and length AB. You can pause the video, refer to the diagram here and find length AB and X. Now to find AB, we can use Pythagorean theorem or we can use the trigonometric ratios. We are given, if you look at the big triangle ABC, is a right triangle. So we are given two sides. 25 plus 15 is the side length BC. So you can add that up and you can use Pythagorean theorem to find AB. To find angle X, since we are dealing with right triangles at present, we should actually find this angle also. Let me call it Y. And then we can find angle X. Okay, so let's begin. So first thing is BC for us is equals to BD plus DC plus DC, which is equals to 25 plus 15, or which is equals to 40. Well, the units are not given, so 40 units. So we know BC. Now to find AB, we can use Pythagorean theorem, or we can use, let us use Pythagorean theorem, okay? So AB is equals to sum of squares of BC and AC, square root, right? So, or we'll write in two steps. AB square is equals to BC square plus AC square. So AB is equals to square root of this. So let's find the squares first. BC is 40, so we have 40 square plus AC square, which is 36 square, right? So AB is square root of 40 square plus 36 square. We can use the calculator and find AB. It is going to be square root of 40 square plus 36 square, which is equal to 4 square root 181, or in decimals we can write this as 53.81. Since the sides are given in whole numbers, we can actually round it to approximately 54 units, right? So that is AB for us. To find angle X, we can find these two angles and then be easy to find angle X. Let us find angle Y first. Since we know the opposite and adjacent side in triangle ADC, which is a right triangle, so we'll consider triangle ADC, which is right triangle. Here opposite side to Y is 36 and adjacent is 15. Since we know opposite and adjacent, we can use tan. So we have tan of Y equals to 36 over 15. Or we can say Y is equals to tan inverse of 36 over 15, right? Now we can find the value of angle Y. Second function tan inverse 36 divided by 15 bracket close equals to 67.380. Right, so that is the angle Y for us. Let us also find angle B. To find angle B, we can use the big triangle ABC. So in triangle ABC, tan of angle B is equals to 36 over BC. BC is 40. So from here we know angle B is equals to tan inverse of 36 over 40. I'm not reducing it since we are using calculators, so we're kind of spoiled. So we to shift tan inverse within brackets, 36 divided by 40 bracket close equals to 41.98. So that gives us 41.98. So we know this angle for one is, let's write this as 42 degrees, and angle Y is, let's approximate it to 67 degrees, right? So if we do that approximation, then we can find angle X. So what is angle X? Can you tell me that now? If you remember the exterior angle, now Y is exterior angle, right? So Y is equals to sum of these two, right? So therefore Y equals to angle B plus X. Is that okay? You could use that. Or you could also find this angle by doing 180 minus Y, and then 180 minus some of these will give you X. So either way you can solve it, right? So I will use exterior angle. So I know X is equals to angle Y. Let me write Y. I could have written measurement of angle Y minus angle B, right? Measurement of angle B. So which is equals to angle Y 67, we rounded them up, minus 42. Let me round this and write here as 42 degrees. Okay, minus 42 degrees, correct? So X is 67 minus 42. 7 take away 2 is 5, and 6 take away 4 is 2. So 25 degrees is our answer. So that is how we can find both side and the angle. So our answer here is AB is equal to 54 units and angle X, or X we can say, is equals to 25 degrees. I hope that helps. Thank you and all the best.